Good morning, students.
Good morning, sir.
Right. So center of mass we were studying. Okay. And yesterday we finished motion of center of mass, like what is velocity of center of mass, how to calculate velocity of center of mass, acceleration of center of mass. And today I told you that we are going to have very important topic that we have to discuss of this chapter. Okay, what is that? Conservation of momentum. So see, yesterday we discussed something like acceleration of center of mass. In motion of center of mass, we discussed that acceleration of center of mass is equal to m1a1 plus m2a2. Suppose there are two particles, okay? m1a1 plus m2a2 by m1 plus m2. This is what we discussed. And before, when we started the chapter, we said that if there is a system or there is a big object in which there can be multiple particles. Okay, there are multiple particles in this one. Its mass is m, let's say. And when you are applying the force on this, then this force we call as m into acceleration of center of mass. Right, this we discussed. This is which force? External force. Or net external force, whatever you say that. Okay. So net external force is equal to total mass into acceleration of center of mass. So fine. Let's come over here. What this m1 plus m2 is? That's again total mass of the system because we are having two particle system only. So this basically represents total mass of the system. Take it over here. So it becomes m1 plus m2 into a center of mass, acceleration of center of mass equal to what? m1a1 plus m2a2. Fine, no problem in that. But if suppose there is no external force acting on the system, okay, if external force on the system is zero, if external force on the system is zero, then what will be acceleration of center of mass? Zero. If this external force is zero and we are writing MACOM here, what is ACOM then? Mass cannot be zero. Mass is not zero. Mass is there. Mass cannot be zero. So then what is zero? Acceleration. If this is zero, then acceleration of center of mass is zero. And okay, correct. Okay. So here, if we are saying the same thing I'm applying over here, say F external is zero. F external is zero means this zero. That's what. So this is zero. So this is zero means what? Says m1a1 plus m2a2. m1a1 plus m2a2. If external force is zero, then acceleration of center of mass is zero. But does it mean that acceleration of individual particles is zero? No. Individual particles can accelerate themselves. Okay, because of the internal forces. There are internal forces also. There may be internal forces. What type of internal forces are possible? We'll discuss that. We'll discuss. Okay, but m1a1 plus m2a2 will be equal to zero. Okay, because external force is not applied on that. So let me write in another way also. Minus m1a1 equal to m2a2. You know what this is? From here only Newton's third law came. This is Newton's third law. How Newton's third law came? Suppose I am going to apply the force on the wall. Okay, now me and the wall is a system. Me and the wall is a system. So what happens? The force that I am applying on the wall In return, there is a force applied by wall on you. Both are equal and opposite. See? Action, reaction. You can call this as action. You can call this as a reaction. Both are in opposite direction. M1A1 equal to M2A2. But both are acting in opposite direction. Consider two particles as a system. Now suppose that we are going in a boat. Okay. We have to come out of the boat. What we do? We push the boat back. That's your action on the boat. Then you get a reaction from the boat. That's why you come outside. So you and boat are two particles of a system, a big system. What is the system? Boat and you is a system. So you and boat, both are parts of that system. You applied force on the boat, boat applies on you. Equal and opposite. Okay, more examples I'll give you, but first you note, and if anything is not clear in that, ask. This is important, so it's very necessary for you to understand it. If any doubt is there, ask me. Is everything clear?
Yes, sir.
Okay, note it. Done? Completed?
Yes, sir.
Okay. Let's take another example. So a few more examples of this one. Okay. Now, suppose we have two planets. Two planets we have, or Sun and the Earth. Okay. The Sun is here and Earth is here. Okay, this is system. My system is this. This is my system. Okay, now suppose Sun is attracting Earth in this direction, and Earth is attracting Sun in this direction. What these forces are? External or internal? Internal forces. Okay, this and this both are what type of forces? Internal forces. They are internal forces. Because I cannot see any other force which is coming from outside. This is internal force. They can apply on each other. Even they can collide also. Where they collide, if suppose I take a system in which, let's say I have a container and inside gas is there. What gas particles are doing? They are running. They are running and colliding. Collision is happening. So when they collide, when they touch each other, they apply normal contact force on each other, contact force on each other. They do apply. What type of force is that? Internal force. Okay, because we didn't apply any force from outside on the container. We didn't apply. So internally, whatever they are doing, that is internal force. Okay. The same way, this is internal force. Now, suppose because of this one, this Earth is moving, let's say with some acceleration, let's say A1. And because of this, Sun is moving with acceleration. What we can write? What is acceleration of center of mass? Acceleration of center of mass is 0. Why? There is no external force. If external force is not there, then the acceleration of center of mass is 0. Does it mean that Sun and Earth are not moving? No, they are moving. Earth is moving because of the Sun. We know that its motion is because of the Sun. There is a force acting. And same way, Sun also gets influenced by these Earth's attraction force. So both have a motion because of each other. So we can write here ACOM is 0. Perfect. Sorry. Okay, fine. ACOM is this, but what is this actually? Mass of the Sun into acceleration of the Sun plus mass of Earth to acceleration of Earth by total mass. That is valid here also. So if this is 0, doesn't mean that their accelerations are 0. Remember, if F external here is 0, acceleration of center of mass 0, yes, no doubt. But is this 0? No. Is it really happening? Yes, it's happening really. Okay, this is one example. Second example, if I give you electrostatic force, two charges. Say two charges are given. This Q1 and this is Q2. Both are applying force on each other. Repulsive force. Because of this force is here, because of this force is here. Any external force is there? No external force is there. So acceleration of center of mass is 0 here also. Does it mean that they are not going to move? They are going to move. This will be moving in this direction with A2. This will be moving in this direction with A1. Action, reaction. Action on Q2, reaction on Q1. So electrostatic force forms action-reaction pair. Gravitation force forms action-reaction pair. Magnetic force forms action-reaction pair. Okay, so if acceleration of center of mass is 0, still the particles can move. They are moving in such a way that the acceleration of center of mass is 0. One more example I'll take. More relevant to the topics, more relevant to what we have studied so far. Spring. Spring is there. This is one mass and this is the other mass. Okay, M1 and M2. Now what we did is we compressed it. I compressed it. This is M1. Now it's like this. Oh, I changed the M1 and M2. Okay, one minute. Let's change it. This is M1. Oh, this is M1 and this is M2. Okay. So it's like this. Fine. What we did, we compressed it. I compressed it. I'm external? Yes, I'm external. But I'm going to leave it now. So when I'm going to leave the spring, what is the acceleration? 0. I'm going to leave it, okay? Now, when I'm going to leave, the spring is going to apply a force on this one to move like this. And spring only is going to apply the force on this to move like this. Is external force involved in that? No. Initially, I compress the spring. True. But have I given it motion? No. I'm going to release it now. So when I'm releasing, is the system moving? No. So when I leave also, the system will not move. Why? Because before I left, it was not moving. Now, because of what these particles are moving? Because of spring. Spring is getting into its natural shape. So spring is basically internal force. So both the particles will go like this. Okay, and they will go in such a way that acceleration of center of mass will be 0. We'll see that, okay? Its acceleration will be A1, its acceleration will be 0, A2, and ACOM again is 0. So here also I'll write M1 A1 plus M2 A2 equal to 0. Okay, and from this law, what came? Newton's third law. Is this clear?
Yes, sir.
Note that. Completed?
Yes, sir.
Okay. Now let's move ahead. But before that, shall I ask you one question? Now you can give me the answer very easily. Okay. Question I'll ask you first, okay? Let's frame a question on this. The question says that two masses, let's say this is 2 kg and here is 3 kg. Okay. Question is saying that both masses are coming towards each other due to their attraction force. Due to their attraction force. Find acceleration of center of mass of the system. Okay. Let's assume this is going with 3 meters per second square. And this is coming due to something like, what shall I say, 4 or 1 meter per second square. 2 meters per second square. What is the acceleration of the center of mass? What will you give me the answer? Note the question first. Yes, students, what will be your answer? Okay, see on the board. Have you completed the question?
Yes, sir.
Okay. Now, first thing is, if you read the question, they say that they are moving due to their attraction force. Their attraction force. That means if this is a system of two particles, is there any external force on that? No. External force is not there. If external force is not there, why to calculate anything? We know acceleration of center of mass is 0. Finished. If external force is 0, that means acceleration of center of mass is 0. Understood that? Is it clear? Tell me fast.
Yes, sir.
That's it. This is the concept. Why to calculate? If external force I can't see, that means acceleration of center of mass is 0. Finished. Over. Note this, then I'll change the question. Completed?
Yes, sir.
Okay. I'm changing the question now. And the change is okay. So the change here is its acceleration is 5 meter per second square. Okay, and here changes. Find acceleration of 3 kg mass. That's the question for you. 2 kg mass is moving with 5 meter per second square. Find the acceleration of 3 kg. Come on. Try. What's coming?
Sir, minus 10/3.
Yes. When we say external force is not there, we can't see any external force. So if external 0, okay, that means MACOM is 0, but MACOM is what? This is M1A1 plus M2A2 equal to 0. M1A1 means 2 into 5. So 2 into 5 I cap. Put it in vectors, there is no problem. 2 into 5 I cap. Now plus 3 into A2 equal to 0. So 3A2 minus 10 I cap. So A2 is what? Minus 10 by 3 I cap. Is it clear?
Yes, sir.
Any doubt in that? Is the board clear? Everything is soothing to your eyes or it's creating problem? Because I have changed background. You are seeing that background is different today. Is this soothing or the previous one was better?
Both are fine, sir.
Okay, so if it's fine, then okay, we'll have it. Completed, students?
Yes, sir.
Okay, now let's move ahead. So what we did so far, we said that if external force is 0 on the system, acceleration of center of mass is 0. Perfect. If F external is 0, acceleration of center of mass is 0. Fine. Now, if acceleration of center of mass is 0, what does that mean? That means velocity of center of mass is constant. If acceleration of center of mass is 0, that means velocity of center of mass is constant. That is only acceleration of center of mass. The acceleration 0 means what? Change in velocity is 0. A change in velocity is 0 means velocity is constant. Simple. VCOM is constant. Now, what does that mean? VCOM is actually M1 V1 plus M2 V2 by M1 plus M2. Right? This is only. So M1 plus M2, if this is constant, so that means M1 plus M2 into VCOM. If this is constant, VCOM is constant, means this is constant. What is this? This is momentum. This is called momentum. This is momentum. Momentum of the system. That means momentum of system is constant. When external force is 0, momentum of the system is constant. Acceleration of center of mass is 0, perfect, we did it. Now I'm saying if external force is 0, momentum of the system is also constant. It will not change. Internally, velocities are constant. No. They may change. Why? Because acceleration is there. M1, A1 plus M2, A2, we saw this a little while ago. So internally, their velocities may change. But velocity of center of mass will remain constant. Momentum of center of mass will remain constant. Why? Because there is no external force, there is no acceleration of center of mass. Is this clear? Very, very important point this is. Very important. If external force is not acting, velocity of center of mass is constant or momentum of system is constant. Note this point. Completed?
Yes, sir.
Okay. So momentum of system is constant, we learned. Fine. Now this concept where we are going to use? Many places. How many places? Let's see. First example of this where we use is recoil of the gun. Recoil of the gun. What recoil of the gun? When we are going to fire a bullet of the gun, okay, is there any external force which is giving the velocity to the bullet? No. No, there is no velocity given by external force. Bullet goes out, gun goes backwards. It's called recoil. Why it is like this? Because no external forces apply. If one particle goes forward, then second particle has to go back. Okay, that is the example of conservation of momentum. I'll give you the question. Okay, then there are more. We'll see them. Okay, in the form of numericals only we'll see. So recoil of the gun, we are saying. Okay, recoil of the gun. If I can frame a question right now, maybe like this. Let's make a pistol over here. If I can make it correctly. Okay. Okay, let's try. Okay, something like this will be a pistol. No, not like this. It will be like this. The pistol like this. Now, in pistol, what we do? We are going to pull the trigger, right? We pull the trigger. But when we pull the trigger, okay, we are about to make it the final thing. Is anything in motion? Nothing is moving. What you are doing basically by pulling the trigger, actually inside there is a spring. You are compressing that. Exactly what I told you in little while ago, that there are two blocks which are connected with the spring. Okay, and these two blocks I am going to compress. I brought them very close. M1 is here now, and M2 came here. What I did is I compressed the spring like this. But at this position, is anyone in motion? No.
No.
Rest. Now I'm going to release. So when I'm going to release, what is the acceleration of center of mass? 0. Now I released it. So why they are going? They are going because of the spring. And what is spring? Internal. Spring is internal. Is there any external force? No. So because internal force they are moving, and this in this direction, this is this direction. Exactly same thing is happening over here. In this one, what I am doing? I am pulling the trigger. So pulling the trigger means what? Inside there is a spring. I am compressing it. Okay. And at the time of when I want to fire it, okay, what I'll do? Just click it. And suddenly, bullet will go that direction and gun will go another direction. We call that as a recoil velocity of the gun. Okay. This gun goes back. Bullet comes forward, goes forward here. Say bullet goes forward. And the gun goes backward. This is called recoil velocity of gun. That means with what velocity it will come back. If you have seen in movies also, they will fire, then what will happen? There will be a jerk in their hand. It goes like this. That is because of that. But if you see in two soldiers carry large guns. Okay. So they will take it with the help of their shoulders. They will put it on the shoulder and then they fire. Reason is because that is coming back and shoulder can stop it. So that's why they take the support of shoulders. If it's even bigger, then put it on the ground. They'll put it on the ground and make their frame. It goes inside and then they will fire. They lay down and they fire so that they can save themselves. Because if you are firing so many bullets at a time, even your shoulder cannot take it because the jerk is huge. Okay, so this is called what? This is called recoil velocity. So just write the example. Okay, then we are going to solve the question based on that. Done?
Yes, sir.
Okay. So let's frame one question and solve it based on bullet and gun. Okay. I'm making one question. See. The question is a bullet of mass 20 gram is fired with velocity of 100 meters per second from a pistol of mass 2 kg. From a pistol of 2 kg will be heavy, right? 1 kg. Pistol of mass 1 kg. Find recoil velocity of the pistol. Recoil velocity of the pistol. Okay, note the question, then you'll solve it. Done?
Yes, sir.
Okay. So now we all know that how this works now. There is nothing new. So before firing, what system is there? Is it at rest or is it in motion? Before firing, it is at rest. Okay. And when you fired it, any external forces there at that moment? No. There's no external force. What I told you that you may think like because we are triggering, so definitely we are involved, we are external for the system. True, we are external for the system. But when we have fired it, that means we compressed it. But just before that bullet is going to leave, are we doing anything? Are we giving motion to the center of mass? No, we are not giving. We have just compressed the string, nothing else we did. Now we are going to leave it. So at the time of leaving, have we given any motion to anything? No. We are not giving any motion. So just before the bullet came out, is anyone moving? No. Okay. So what is the just see that what I am taking, okay? Because that is how we are going to solve all the questions. Okay. So just before firing. Now when I say just before firing means this is the incident just before bullet came out. Okay, just before firing. Now tell me, just before firing, what is the momentum of the system? 0. Because neither bullet has moved, nor gun has moved. Both are at rest only. Just before firing. So it's a momentum is 0. Momentum initial, you say, is what? 0. Perfect. Any external forces involved in this process? No. Acceleration of center of mass? 0. That means momentum after firing also will be 0 only. Because there is no external force involved. So momentum remains constant. Okay. So since external force is 0, momentum of the system remains constant. Momentum, okay, I should write it with a different color. momentum of system remain constant, remain conserved. Okay, fine. Momentum of system remains constant. Initial is 0, so it means final also will be 0. Final also will be 0. But what is final? In final, bullet is going. That means after firing. When I am writing momentum initial, it is just before firing, and when I am writing momentum final, it is just after firing. That means we are going to see an event happening. What is the event here? Firing. So just before firing momentum and just after firing momentum is constant. Why? Because no external force is there. Fine. So momentum final is also 0. Then what we can do? Okay, let me erase this now. Okay, so momentum final is what? Momentum final means m1 v1 plus m2 v2. Why? Because both are in motion now. So m1 v1 plus m2 v2. But what is momentum final? 0. 0. Why? Because initial also was 0. Put 0 here then. 0 equal to m1 v1 plus m2 v2. Put the values. M1 is what? 20 gram. So 20 gram. V1 is what? 100. Now check here in this one, I have kept, this is in gram. So M2 also I'll keep in gram only. So what is M2 actually? 1 kg. Okay. 1000 into V2 equal to 0. So bring this one this side. This is 20 into 1000, 20 into 100 negative equal to 1000 into V2. This 3 zeros and this 3 zeros cancel. So V2 is coming minus 2 meters per second. Minus because it's in opposite direction. So your pistol will come back with what speed? 2 meters per second. Is this clear?
Yes, sir.
Okay, note it. Completed?
Yes, sir.
All right. Let's make another question then. So gun and bullet, you remember. Now bullet can be even cannon also. Cannon and what? From the cannon, the big balls will be coming. Okay. The cannon and the ball and all that, they are all based on conservation of momentum. Okay. Right. Let's make another question. Now, this time question is, there is a platform. Okay. There is a platform here placed on the ground and this is smooth. Ground, this plank's mass you can say is M and its length is L. Okay, and there is one boy is here. Boy's mass is smaller. Right? Everything is addressed, no problem here. But now suddenly this boy starts moving on the plank. And Reach is going to the other end. He started walking on the plank and is going to the other end. Question is asked, what is the velocity of the plank? What is the velocity of the plank? If this boy is moving, how is moving actually? How we move? We move because we push the ground backwards. Okay, if you observe, what we do is we push the ground back. We apply the force on the ground backwards and ground gives us reaction forward. So we go forward. Okay, so here also this boy is actually what is he doing? He's pushing the plank back. And since there is no friction over here, there is a smooth. What will happen? This plank will go back and this boy will go forward. Okay, that's action reaction happening over here. What we want here. I'm going to give a question related to velocity. So see, I'm framing the question now. Find velocity of plank if boy moves with velocity v relative to plank. Okay, he is moving in this direction. Find velocity of plank if boy moves with velocity v relative to plank. Okay, note the question. Completed?
Yes, sir.
Okay. So now in this question, we again know there is no external force. There is no external force in this either. So we know momentum is conserved. But momentum we conserve before any event. Now, what is the event in this? Walking of the boy. So before he starts walking and after he starts walking, we have to conserve momentum. Okay. So first thing is, yes, we know F external is 0. Yes, we know momentum is conserved or momentum is constant. Okay, so what is initial momentum? Initial momentum before he starts walking. Okay, what is initial? Initial momentum is 0, we know. But what is initial? Before or just before, you can write. Before boy starts walking or starts moving. What do you have written? Walking or moving? Moves. It's 0. Final also should be 0, but we know that boy will go in that direction and plank will go in that direction. We know that. I assume that plank will go with Vp, velocity of the plank, like that. Okay. So I'm writing final momentum. Final momentum also will be 0, but what is this final momentum? Just after boy starts moving. Okay, but we know this final momentum, both boy and plank has started moving. So I'll write m into velocity of the boy, vb, plus m into velocity of the plank. Right? But this is equal to 0. Fine. Now, up to this point, any doubt is there?
No, sir.
Any doubt is there in this one? Everything is fine? Okay. Now, first you note. Okay, because to come to the velocity of boy, I have to explain a little few more things. Okay, first you note that. Then,
Yes, sir.
okay. Now see, in this question, one thing is given. Relative he gave. Relative. Where is it? Yeah. Oh. Relative. This term. Now, what is this meaning? That means relative means what? He's saying velocity of boy with respect to plank is v. Velocity of boy with respect to plank is v. But I don't require that relative thing. I require velocity of boy. So I can't put v directly. Then what you'll write? Okay, we know what is the meaning of that. This is vb minus vp equal to v. So what is vb? v plus vp. What else? No problem. Now I'm going to write it over here. M, this is v plus vp plus m into vp. And what is here? This is 0. So what we got? mv plus mvp plus capital MVP. Here is 0. Bring it here. Minus mv. And this side, vp you take common. It's m plus m. Right. Then bring it down. So minus mv by m plus m equal to vp. That is what asked from us. This is velocity of the plank. Did you understand? This was the new thing. Is this clear?
Yes, sir.
Remember always, when you are writing this momentum, okay, everything you keep with respect to ground. With respect to ground. Everything in this one. Put with respect to ground. Vp is with respect to ground. So velocity of boy also should be with respect to ground. But what is given in this question? It is given with respect to plank. So first convert it with respect to ground and then keep it. You'll always get correct answer. Okay? Note it. Done?
Yes, sir.
Okay. Right. Now let's move to another concept. What this new concept is? Again, it is interlinked, obviously. F external is 0. We are on that only. So yes, if F external is 0. Fine. Acceleration of center of mass is 0. Fine. No doubt about that. Momentum is constant. Yes. Momentum is constant. Yes. That means velocity of center of mass is constant. Perfect. No doubt about that. But if suppose velocity of center of mass is 0, velocity of center of mass is constant. Okay. If velocity of center of mass is 0, then it will remain 0 only. That's what we saw in the previous cases, like bullet and the pistol. Initial velocity was 0, or initial momentum was 0. So final momentum also 0. Previous case also, boy and the plank. Initial momentum was 0. So final momentum also 0. What I'm trying to say? I'm trying to say if VCOM is 0, then center of mass will not move at all. Then center of mass will remain at its place. Because velocity of center of mass is 0 means what? It will remain at its place. What else? COM will remain at its place. It will not move. CM is fixed. COM is fixed, not CM. COM is fixed. Now this is a different concept. And on this one, there will be different type of questions. Note it. Done?
Yes, sir.
Yes.
Okay. Now let's see question based on this. Question. And let's start with the same question that we did little while ago. Here is a plank. Mass M. Length L. Boy. Mass M. It's like this. Okay. Boy starts moving, reach the other end. He goes to the other end. Then the question asks, how much the plank has moved? What is the displacement of the plank? Okay. The question is, a boy on plank moves and reach the other end. Reach the other end. Find displacement of the plank. Find displacement displacement of the Planck. Previous case we found velocity. Now he's asking displacement of the Planck. Note the question. See how we'll do it. Done?
Yes, sir.
All right. Again, what I know in this? No external force, no acceleration. Velocity is 0 because it's not moving earlier. So velocity of the system will be 0. So center of mass will remain fixed. Wherever center of mass is, it will remain fixed. Okay, simple. Now, what has happened? I'm just making the diagram, okay? Then we'll try and understand and solve the question. Solving is very easy. We can solve it very easily. Okay, so see what has happened basically. Now this Planck. Okay, instead of making it separately, let me make it on that only. Planck has moved this side. Yeah. So Planck has moved this side. Maybe this end has come over here. Okay. It's like this now. Are you able to see that? Are you able to distinguish yellow color and white color? Or shall I make it with a different color? Tell me. Are you able to see this yellow color over here? No?
Yes, sir.
No, if not, then I'll make it even some other color, okay? Just a minute. Let me make it black. I think black will be better. So let's take the help of the black color. And ASO there. Okay. Like this. Visible?
Yes, sir.
Right. So what has happened now? This Planck has moved this side by x. Suppose because x, how much Planck has moved, that is what we are finding. So I assume that this is x. Okay. What we have to do in this? Till now what we did? We said that the initial is 0. So in this direction momentum equal to in this direction momentum. m1 v1 plus m2 v2 equal to 0. m1 v1 equal to minus m2 v2. Here also the same thing. Here also same. So how much it has moved in this direction into m equal to how much the person will be moving on that direction into m. Okay, so see now, I'm considering that initially center of mass is at origin. That's my assumption. Okay, how to solve this? First is assuming that COM is where? 0 at origin. COM is at origin. Fine. Now what has happened? Once the boy started walking, boy has gone towards right and Planck has gone towards left. Okay, one has gone towards positive side, other one has gone towards negative side. That's it. So assuming that center of mass is 0, 0, boy has gone towards right and Planck towards left. Simple. Yes, we are able to see that boy is going like this. Its velocity is like this. Going that direction, Planck has gone left. Okay. So then, where is center of mass? 0, 0. Where it will be? It will remain at 0 only. So final position of center of mass I am writing just C. COM final equal to, let's say what? M1 into displacement of M1. Okay. M1 into displacement of M1 plus M2 into displacement of M2. Here M1. That's all. Nothing more. Shall we do? That's it. Over. So center of mass is where? At 0. Now, what about this boy? Where is this boy now? This boy is here. Now boy is here. Why? Because that is only the Planck's end. Planck has moved that side. So how much block, but this boy has moved. Boy has moved from here to here. And how much is this? Check and tell me, please. This is initial position. This is final position. How much boy has moved? Who will tell me?
L minus X.
Perfect. L minus X. Why? Because this is X? No. This is X. Are you able to understand? This is moved this side. So obviously this end also will move, no? Yes or no?
Yes, sir.
Because Planck's length is L. Planck's length is not increasing. Planck is on L length. So this much is L actually. Now this is moved. So this also will move. No. How can this end be here only? So this end has also moved. How much? X. This was L. This is X. So how much is this? L minus X. So how much boy has moved? L minus X. Displacement of boy is L minus X. M into L minus X. Perfect. Plus M into what? How much Planck has moved? X. But it has gone towards left. So better you write it as. That's it. Over. Finished. Everything is done. This mx, if you want, you can bring it that side or let it be here only. This is m into L minus mx minus mx. And here is 0. Okay. So what we are getting? Now bring this side. Say ml minus ml equal to, take x common, minus x common, becomes m plus n. This and this gets cancelled. What is x? It's ml by m plus n. Is this clear? Any doubts, students? Please ask. Students, any doubt is there?
No, sir. No, sir.
Okay, note then. Completed?
Yes, sir.
Okay. Now, same question again I am giving you, but with values. Just solve this question, okay? With values. So here it is. Same question, okay? This is 5 meter. Its mass is 10 kg. Boy's mass is 50 kg. Same question, okay? Boy's mass is 50 kg. Find, and one more thing. This is smooth. Okay. Find displacement of the plank if boy walks to the other end of the plank, to the other end of the plank. Right? Now, come on. Don't see the formula, okay? Directly you can put into the formula and give me the answer, I know. But don't do the formula. Just try to solve it. Okay, like initial position of center of mass is 0. Final also will be 0. So, the motion of boy, mass into displacement of the boy on one side equal to mass into displacement of plank on the other side. Just put it into that one and solve it. Okay, and give me the answer. We all know the answer, okay? We all know the answer. Yes, students, are you able to do? Make your diagram, and in the diagram, show that our plank has gone X on the left side. X. New position of the boy. Now, this is also X, obviously. New position of the boy is what? 5 minus X. Then we are writing. Where is center of mass? I assumed it as 0. Boy has moved how much? 50 into 5 minus X. How much plank has moved? X. So what it is? 250 minus 50x minus 10x. So here is 250 minus, and this side is minus 60x. This gets cancelled. X equal to 250 by 6. Red color is not good for eyes, right? Too much shining, no? Students? Red color is okay for the eyes?
Yes, sir.
Okay, no problem then. So x equal to 250 by 60. That is x equal to 25 by 6. Has everyone done that? in this way, not in that way, not in the terms of formula. In this way, is everyone done?
Yes, sir.
Good. Good. So that's all for today. Okay. Tomorrow, 1 or 2 more questions I'll take from what we studied today, and then we'll go on to collision. Not tomorrow. Tomorrow we don't have class. Saturday we will see if it's possible. I'll take the class, or otherwise we will have it on Sunday. Okay. So tomorrow no class, but in the next class, few questions from this, then collision, maybe 2 classes more. Then collision is also over, and we will be moving on to system of particles or rotation. Okay, students, is it clear?
Yes, sir.
Sir,
Yes, sir.
sir, our evening class is there, no, sir, today?
Yes, sir. Evening class, we'll talk in evening. What happened?
Yes, sir.
Yes, sir. Okay, students. Bye-bye then. See you.
Thank you, sir.
Thank you, sir.